Hi everyone, and welcome to The Sleepy Scientist. I'm really happy you're here. Tonight, we're going to go on a calm and quiet trip to learn something amazing. So get comfy, take a deep breath, and let's enjoy this peaceful science story together. Before we start, tell me in the comments, where are you watching from and what time is it for you right now? If you like relaxing science videos, don't forget to tap the like button. Now let's begin.
Far from the warmth of the sun, where light becomes a memory and silence hums like a second skin, there lives a world draped in blue, deep, quiet blue. Neptune, the outermost of the great gas giants, spinning slowly in the cold theater of our solar system. It is a place almost no human eye has ever truly seen, and yet something has awakened there, a flicker, a curl of light, an aurora. Imagine standing on an invisible ledge in space, looking down through the shifting clouds of Neptune. The winds there are faster than any storm on Earth. They rush and tumble like ghost rivers, spiraling at thousands of kilometers per hour. But under the bluster and ice, something gentle stirs, a dance of particles, a signal, as if the planet itself were whispering to the stars in colored light. The auroras we know best belong to Earth, green ribbons unfolding above pine forests, shimmering over frozen lakes. They're born when the sun sends out a breath, a solar wind, filled with charged particles. Our planet's magnetic field catches this wind, guiding the particles toward the poles, where they brush against the upper atmosphere and bloom into light. But Neptune is something else. Its magnetic field is wild, tilted far from its spin, lopsided and unpredictable. It loops and dips like a wandering thread. It's not neatly wrapped like Earth's. Instead, it shifts and stirs like a stormy dream. And this strange, skewed field may be the key, the secret, to how its auroras are born. Recently, through the eyes of powerful telescopes orbiting far above Earth, astronomers caught something they had only imagined, a flickering glow far off in the cold. A first glimpse of auroras on Neptune, not green like ours, not red like Mars, but delicate hues of violet and blue, like a secret lantern lit beneath a sea of glass. Let's drift deeper now, to where light has no name. Beneath Neptune's swirling clouds, the pressure climbs. The upper layers are mostly hydrogen and helium, touched by methane, the gas that gives the planet its haunting azure. But deeper still, far beneath the storms, there may be oceans not made of water, but of slush and ammonia, or even an exotic, icy soup where diamonds rain downward like seeds. It's in this turbulent, electric interior that the magnetic field is born. On Earth, our magnetic field comes from molten iron in the core, a spinning dynamo of heat and motion. But Neptune's comes from a different place. Scientists believe it forms not at the core, but somewhere higher within the icy layers, where salts and ices churn together. This irregular generator might be why Neptune's field dances so strangely, so tilted and chaotic. And still, into this dance come particles from the sun. Though the sun's light is faint at Neptune's distance, barely 1/900th of what we feel on Earth, its wind still flows. It reaches, it touches, it plays upon the edge of Neptune's magnetosphere. The charged particles collide with the planet's atmosphere, and in that moment something rare happens. They spark a glow, just a whisper of light, but enough to be seen if one watches closely enough and waits. There is no sky to watch it from, not the way we see skies on Earth, but instruments that can read ultraviolet light have caught it. The signature is faint, like the echo of a firefly in winter, but it is there. Neptune, for all its silence, shines. And what does it mean to witness this? To see a planet more than 4 billion kilometers away flicker softly under the breath of the sun, it means that even in the loneliest corners of space, beauty blooms. It means that light can still find a way. That magnetism, electricity, and charged air, the ingredients of an aurora, do not belong to Earth alone. They are cosmic, they are universal. They are the quiet language of stars and planets alike. You can almost feel it, can't you? The way the particles fall into the atmosphere. The way the energy travels, humming through invisible fields, sparking silent fireworks in a place no foot has ever touched. No sound, no movement, just the steady, slow unfolding of light born in the dark. In this story, Neptune becomes not just a planet, but a lantern, a signal, a place where the universe keeps a secret, glowing in colors too soft for eyes, too distant for dreams. And now we know it's there. The auroras of Neptune remind us that even in coldness there is motion, in distance there is connection, and in silence there can still be song. Let's drift deeper where the air has no edge, and the concept of time is pulled long like thread unraveling through deep space. Neptune's aurora is more than light. It is a soft echo of cosmic energy, gently translated into color. And to understand why, we must follow the path of a single particle, from the sun to the icy border of this distant world. Imagine it, a tiny charged particle, born in the fiery furnace of the sun's corona. It leaves the surface with a burst of energy caught in a stream with billions of others, riding the solar wind like dust caught in a breeze. This journey will take it days, even weeks, gliding past planets we know so well: Earth, Mars, Jupiter, Saturn, all glowing in their own right. But the particle is pulled onward toward a world that spins in near darkness: Neptune. And though Neptune feels far away, its magnetic field stretches out like invisible arms, a cocoon of protective energy. As the particle nears, it is caught, not stopped, not shattered, but guided. The field curves it gently, drawing it in toward the planet's magnetic poles. But unlike Earth, those poles are not where you'd expect them. They lie at strange, tilted angles far from the geographic axis. This means the auroras of Neptune don't bloom in rings near the poles, they twist and wander, drifting like mist. And the particle, it finds the upper atmosphere, mostly hydrogen and helium, and slams gently into it. There, in that quiet collision, energy is released. It excites the molecules. They shimmer. They emit ultraviolet light. And though no human eye can see it unaided, special telescopes tuned to ultraviolet wavelengths can catch that glow like fireflies behind a curtain. But there's more. Unlike Earth, Neptune's auroras don't pulse with a steady rhythm. They flicker, they stutter, they seem to appear and vanish almost at random. This could be because Neptune's magnetic field is unstable, a broken compass made of swirling salts and frozen seas. The shifting nature of the field may cause the auroras to migrate, to fade and return, always moving, always hiding. And sometimes the auroras seem to spark not from the sun's wind, but from Neptune itself. You see, deep inside Neptune there is warmth. Though the surface feels frigid, nearly -220 degrees C, the planet gives off more heat than it receives from the sun. No one knows exactly why. Some think it's the leftover heat from its formation. Others wonder if diamond rain, falling through layers of ice, releases energy. This internal warmth may drive storms, create pressure, and stir the magnetic field. It may even generate its own charged particles, particles that spiral along the magnetic field and cause auroras without ever needing the sun's wind. It's as if Neptune glows from within, quietly lighting its own night sky. Now picture this, a dark hemisphere turning slowly through space. There are no continents, no cities, just bands of wind, rings of faint dust, and one or two icy moons drifting nearby. Above it all, a ghostly aurora curls through the upper atmosphere, visible only to instruments thousands of kilometers away. It's a secret show, witnessed by no one, and yet it happens again and again, written in light. Even Triton, Neptune's largest moon, may feel the magnetic embrace of these auroras. Though locked in orbit, it dances close enough that its thin atmosphere may shimmer faintly when the magnetic field flows just right. In this way, the light becomes a bridge between the planet and its moon, between matter and energy, between what we know and what we only guess. And there's something gentle in that, something soothing. Because Neptune's auroras are not sudden explosions, they do not roar or crackle. They rise slowly, fade quietly, and return without notice. They are soft signs that even in a world so cold, so far, beauty does not sleep, it only whispers. The science of it all, the fields, the charged particles, the collisions, can be described in numbers, in graphs, in careful equations. But lying beneath all that is wonder, pure, quiet wonder. That magnetism, the invisible flow of electric energy, could sculpt such grace into the sky. On Earth, we see the aurora and feel awe. In Norway or Alaska, we gather and look up, watching the sky fold itself into green curtains and scarlet veils. But Neptune's light is not for watching. It is for listening, if one listens in the language of physics, of field lines and spectral emissions. It speaks in wavelengths outside our eyes, yet it sings all the same. And so, in this second step of our journey, we have followed a trail of light from the heart of a star to the breath of a faraway world. We have watched it spark, fade, return, and in doing so, we have learned that auroras are not just local wonders. They are universal. They belong to the fabric of the cosmos. You can almost imagine the pulse of it, quiet, steady, glowing, as Neptune turns slowly beneath its ever-shifting sky. And in that silence, we begin to sense something greater still. Now let us return one final time to the quiet orbit of Neptune, not to study, not to measure, but to feel, to listen, to stand at the edge of imagination and press our thoughts gently against a world that glows unseen beneath the weight of ice and time. Neptune, that distant wanderer, turning in the dark like a lantern behind a curtain of frost. The aurora here is no longer just a phenomenon. It is a poem written in the invisible ink of the universe. It is a reflection of motion, of energy traveling across impossible distance, of magnetism made visible. When you think of it like this, Neptune becomes more than a planet. It becomes a place where light and gravity are in conversation, where silence is interrupted only by the whisper of solar wind. This light, captured for the first time by human instruments, has been happening for eons, long before our telescopes, long before even our questions. As Neptune drifted around the sun, slow and distant, it wore its auroras like a soft halo, a crown of motion that flickered in ultraviolet silence, not because it needed to be seen, but because it simply was, because that's what particles do when they collide in the presence of magnetic fields. They glow. And in glowing, they become the soft fingerprints of unseen forces. We talk of exploration as conquest, but Neptune reminds us that the universe is not waiting to be conquered, it simply waits to be noticed. And now that we've seen its aurora, truly seen it, we can no longer say that Neptune is silent. It speaks, just not in sound, not in language, but in light curled gently around the body of a planet spinning slowly in the black. And perhaps what makes Neptune's auroras so moving is not their science, but their subtlety. On Earth, auroras dazzle. They erupt and stretch across the sky like living rivers, but Neptune's are barely there, faint, ultraviolet, like a sigh too soft for ears. That such delicate beauty can live in such cold and emptiness reminds us that not all things need to be grand to be profound. Sometimes the most powerful stories are the quietest ones. Consider the rhythm of Neptune's seasons. Each one lasts over 40 years. The planet takes 165 Earth years to orbit the Sun. So slowly it moves that entire generations pass in a single Neptunian summer. And yet in this glacial rhythm, auroras still appear. They don't rush, they don't hurry. They flicker in their own time, appearing where the magnetic field bends just right, where a charged particle meets a molecule of gas. Nothing more, nothing less. But isn't that enough? Isn't that beautiful? And maybe, just maybe, Neptune's auroras are more than scientific curiosity. Maybe they are a reminder that we too are surrounded by unseen fields, that our own hearts and thoughts pulse with electricity, that we walk inside magnetic oceans of our own, that the glow we chase through telescopes is not so different from the one that flickers inside each living cell. Because auroras, after all, are made of connection. A spark from the sun, a field from a planet, a moment of meeting, that's all it takes. And maybe the universe is built on such meetings, small collisions that become light. Now imagine Neptune at night, if such a thing as night exists where the sun is only a distant star. Picture the clouds swirling, driven by winds faster than sound, the faint rings circling like whispers of stone and dust, Triton gliding by in slow orbit, and above it all there it is, the aurora, curling softly in a shade no eye can see, a violet sigh, a blue hush, a pulse faint and steady like a heartbeat slowed by time. It's easy to forget this planet is real. It seems like something invented in a dream, but it is there. And now we have touched it with light, not with rockets, not with footsteps, but with understanding, with observation, with wonder. And that may be the most human thing of all, to see something distant, silent, unreachable, and to find beauty in it. Neptune's auroras do not ask for attention. They do not blaze across the sky to be noticed. They exist because the laws of the universe allow them to. They remind us that the universe is always creating, not always loudly, not always visibly, but endlessly, quietly, lovingly. So let us carry that thought with us now, that even in the farthest places, in the coldest dark, something can glow. That light does not need eyes to shine, and that wonder, once discovered, never truly fades. The sky beneath Neptune's sea of ice will continue to flicker, long after we are gone, long after names and nations have faded. The auroras will still breathe in ultraviolet curls, still speak in the soft language of magnetism and wind, still tell a story whether anyone listens or not. And in knowing that, we are no longer so far away. We are part of it. Not the aurora itself, but the gaze that found it, the ears that learned to listen, the heart that understood what it meant to glow without needing to be seen. Deep beneath the swirling clouds of Neptune, far below the winds that scream in silence, there lies a hidden rhythm, one not made of sound, but of invisible motion. A magnetic heartbeat, ancient and strange, pulsing through the ice and gas. It moves not like a clock, but like a wave, unpredictable, shifting, tilting with time. This is Neptune's magnetic field, and though we can see it, we can feel its presence through the subtle signs it leaves behind. Unlike Earth, whose magnetic field flows neatly from pole to pole like an invisible globe within a globe, Neptune's is tilted at a strange angle, 47 degrees off from its axis of rotation, and it is not centered in the planet's core. Instead, it loops and sways, offset and off-kilter, as though the planet's heart spins slightly out of sync with its body. This gives Neptune an identity unlike any other planet. A world whose invisible forces dance in spirals, wrapping themselves like seaweed around its core. It may seem strange to speak of a magnetic field as if it breathes, but on Neptune it almost feels that way. The field stretches and folds, twists and bends, creating a magnetosphere, a great bubble of charged particles and electric current that surrounds the planet like a cocoon. This magnetosphere responds to the solar wind, catching it, deflecting it, and occasionally letting it slip inside to light up the skies with Aurora. But the story of Neptune's magnetic heart begins not in the sky, but deep within the planet. Earth's magnetism is forged in its iron core, where heat and spin churn up liquid metal, creating electric currents that generate the field. But Neptune has no solid iron heart. It is mostly made of water, ammonia, methane, frozen gases pressed into exotic states by pressure and cold. Somewhere within this icy mantle, under conditions no laboratory on Earth can truly replicate, a dynamo is born. The precise location remains a mystery. Some think it may lie in a shell surrounding the core, where ions drift through slushy oceans of chemicals. Others imagine vast rivers of conductive ammonia, stirring slowly, endlessly. Whatever its source, the result is extraordinary. Neptune's magnetic field is not stable. It changes, it leans, it loops in wild arcs. And as the planet rotates, the entire field appears to wobble, sweeping across the solar wind like a broken umbrella turning in a storm. To observers watching from afar, the effect is mesmerizing. A rhythmic rise and fall in radio signals, in auroral glow, in the electric song of Neptune's pulse. The Voyager 2 spacecraft, the only human-made object to visit Neptune, flew by in 1989. It stayed for only a short while, but in that time it recorded a wealth of data, especially on the magnetic field. What it found was unlike anything seen before. Magnetic poles far from the geographic ones, a field that varied wildly in strength, and signs of electric currents flowing through the space around the planet like nervous energy in a sleeping giant. It was as if Neptune itself were humming a low, uneven lullaby. And in that lullaby lives meaning. Because magnetic fields are not just invisible structures, they are guardians. They shield planets from cosmic rays, from solar storms, from radiation that can strip away atmospheres and erode the fragile boundaries of life. On Earth, the magnetic field protects us every moment of every day. And though Neptune has no known life, its magnetic shield still serves a purpose. It shapes its auroras. It sculpts the charged particles that dance near its moons. It even creates distant echoes, radio waves that we can catch and interpret, like a message carried across the void. One such echo is called a planetary kilometric radiation, bursts of radio noise caused when charged particles spiral along magnetic field lines. On Neptune, these emissions pulse in strange cycles, revealing the spin of the field itself. Unlike Jupiter or Saturn, whose magnetic fields are relatively simple, Neptune's radio voice is chaotic, fragmented, singing a melody we have only just begun to hear. And that voice tells us something important, that the magnetic field is not still. It breathes. Not like lungs, but like tides. Its motion is subtle but real. It draws in and pushes out. It responds to the solar wind, to the planet's own spin, to the pull of the moons that orbit close. Triton, for example, moves in a retrograde path, the opposite direction of Neptune's spin. This tug-of-war may stretch the field, twist it further, giving rise to even stranger flows of energy through the magnetosphere. And inside that ever-shifting sea of force, particles move. Some are born from the sun, others from Neptune's atmosphere itself. They spiral, collide, bounce. They race along magnetic lines like dancers tracing invisible paths. These motions create electric currents, which in turn shape the field, a feedback loop of force and movement, complex and beautiful. It's easy to miss how emotional this is. But when you pause and picture it, this distant world, its core hidden beneath layers of cloud and ice, generating a magnetic field so wild, so offset, so alive, you realize that Neptune's magnetism is a kind of story. A story written in spin and flow, in energy and time. A story that says, even in the coldest places, motion never stops, even in and say something stirs. We often think of magnetism as static, as something fixed, but Neptune shows us another truth, that magnetic fields can drift and pulse and surprise, that they can wrap a planet in invisible waves that move like breath, and in doing so they become more than forces, they become character, identity, a kind of music. You can almost hear it if you try, the way the field curls through space, the way it wraps around clouds, around moons, around the memory of Voyager's path, a field not waiting to be measured, but simply living, slow, strange, and strong. So let us stay here a little longer, near the heart of this field. Let us feel the rhythm of its movement, and wonder at how something so vast can still feel so intimate. Let us rest in the knowledge that magnetism, though unseen, touches everything from particles to planets, from the faintest aurora to the deepest core. Because in Neptune's magnetic heart, there is both mystery and meaning. And both are still unfolding. There is something timeless in the way a planet spins, not rushed, not hurried, as though it knows no destination, only the rhythm of turning. Neptune turns quickly, completing a full rotation in just over 16 hours. And as it spins, its magnetic field wobbles and weaves through space like a ribbon in a wind with no beginning. Unlike Earth's neat, centered magnetic swirl, Neptune's field moves like a ghost tide, leaning and drifting, a pulse wrapped in mystery. But what causes this strange behavior? Why does Neptune's magnetic field wander so far from its core, and why does it tilt so steeply from its axis? To understand this, we must imagine a world with no solid ground. Beneath Neptune's pale blue clouds, beneath the roaring winds, there is no surface to stand upon, only increasing pressure, deepening cold, and shifting chemical oceans. It is here, in these deep layers of fluid ice and exotic liquids, that the dynamo begins. Scientists believe Neptune's magnetism may arise not from a metal core like Earth's, but from a shell of electrically conductive fluid, perhaps an ocean of water, ammonia, and methane in a state so compressed and cold that it behaves like a strange, slushy metal. In this inner ocean, movement is everything. As the planet spins, it stirs this conductive layer. Currents begin to flow, and where there is movement of charge, magnetism is born. But because the dynamo lies far from the center, and because the materials within are uneven and slow-moving, the resulting field is uneven too. It loops out wide, offset by thousands of kilometers, twisting into strange shapes. This is what Voyager 2 discovered, a magnetic field not just tilted, but displaced. A field whose lines of force sometimes barely skim the planet, other times reaching far into space. Such a field creates a magnetosphere unlike any other in the solar system, asymmetric, dynamic, alive. Now imagine a particle from the solar wind, a proton or electron perhaps approaching Neptune from deep space. As it nears the magnetosphere, it's swept into this asymmetric web. Some particles bounce off. Others spiral along magnetic field lines, slipping into the upper atmosphere where they trigger the soft ultraviolet glow of auroras. But because Neptune's field is tilted and off-center, the particles enter at unusual angles, lighting up odd places across the planet's sky. The auroras don't follow the neat circles we see on Earth. They drift and shift, appearing where the field lines bend and break. In this way, Neptune's magnetic field becomes a kind of painter drawing soft, invisible shapes across its skies. And while we can't see this with our eyes, we've developed tools that can. Telescopes in orbit above Earth, tuned to the right wavelengths, have caught faint glimpses of these auroras. Instruments on Earth have detected changes in radio waves that match the planet's magnetic heartbeat. Every flicker, every ripple is a message sent across space, a hint of how the magnetic field flows, how it pulses, how it lives. These studies have taught us something extraordinary. Neptune's magnetosphere rotates differently than the planet itself. Because the field is not aligned with the spin axis, it sways through space like a lighthouse beam, sweeping around as the planet turns. This leads to fluctuations in radiation, in auroral brightness, in the charged particles surrounding Neptune and its moons. And it's not only the planet that feels this field. The magnetosphere stretches out to touch Triton, Nereid, and even the faint arcs of Neptune's rings. Triton, with its thin atmosphere and icy surface, may experience induced currents as it moves through the magnetic field. These currents, though gentle, may stir the particles in its atmosphere, or even shape how its geysers behave. In this way, Neptune's magnetism becomes a bridge between the planet and its moons, a quiet, invisible thread binding them together. Even the rings. Feel its pull. Neptune's rings are faint and fragmented, made of dark particles that orbit in narrow, clumpy bands. These particles may carry charge, and as they move through the magnetic field, they could experience tiny forces, twisting, tugging, aligning over time. It is a subtle interaction, but one that adds yet another layer to the story of Neptune's magnetic heart. And what does it mean to know all this? It means we are listening to a planet in a new way, not with sight, but with sense. We are reading its invisible structure, tracing its hidden motions, and what we find is not chaos but rhythm, not silence but song. For centuries, humans gazed at Neptune as a moving star, a distant blue dot at the edge of the sky. Only in recent decades have we learned to hear its voice, a voice made not of sound but of magnetic waves, of shifting light, of electric breath. And in hearing it, we learn that every planet is more than a place. It is a pattern, an expression of forces written over eons. Neptune, with its tilted, lopsided magnetic field, teaches us that beauty does not always come in symmetry. That stability is not the only form of elegance. There is grace in wildness, in movement, in imbalance. There is wonder in fields that wobble and twist, in forces that flicker in and out of reach. And there is peace in knowing that even in the farthest reaches of our solar system, something is spinning, breathing, glowing, that a planet wrapped in ice can still cradle a magnetic soul. You can almost feel it now, can't you? The slow sweep of the magnetosphere, the way it moves like wind through a forest of fields, the way it hums just beyond hearing, touching moons, stirring particles, guiding light, a gentle hand in the vast, silent dark. And in that gentle motion there is a kind of wisdom, a reminder that even the unseen matters, that magnetism, though invisible, shapes the world, that the heart of a planet may beat not with sound or heat, but with the steady swirl of electric dreams. Let us return now to Neptune, to the place where magnetism moves like breath across a frozen sea. We've wandered through the field lines, traced the tilt, listened to the pulse. But before we leave this strange and magnetic world behind, we must reflect on what it reveals, not only about the planet itself, but about the delicate patterns that thread the universe together. Neptune's magnetic field, so offset and unpredictable, was once thought of as a mystery, a puzzle to be solved. But perhaps it is not a flaw in the system. Perhaps it is simply another kind of order, one that resists straight lines and simple symmetry. It is a reminder that nature does not always move in perfect circles. Sometimes it spirals, sometimes it wobbles, and in doing so it reveals deeper forms of balance. Picture Neptune spinning now, alone in the dark. Its axis leans, its magnetic heart swings wide, the field lines twist around it like seaweed in a current, reaching outward then folding back. Within this invisible architecture, charged particles chase paths too small to see, creating flickers of light in the high sky, quiet auroras no human has stood beneath. And yet they are real, they happen, whether we look or not. This is the quiet truth of the cosmos. It does not wait for us to observe it in order to unfold. The planets spin, the fields curl, the winds rise, light travels across distances so great they seem beyond imagining. And within all of this motion there is memory, not the kind we store in our minds, but a deeper memory, stored in the arrangement of atoms, in the tilt of a field, in the dance of a moon around its planet. Neptune's magnetic field is one such memory. It holds within it the story of the planet's birth, the chemistry of its core, the way energy moves through materials under pressure we cannot yet reproduce. Every loop and wobble is a page in a book written in forces and time. And as we learn to read that book, with telescopes, with probes, with theory and wonder, we begin to understand that the heart of a planet is not a place, but a process. It is still spinning, still creating, still surprising. Even from across billions of kilometers, we can sense the rhythm of Neptune's field. We catch it in ultraviolet glows. We trace it in radio emissions. We model it in labs, imagining how layers of ammonia and water might behave under pressure, how charged molecules might stir in planetary depths. In each effort, we are building a bridge between what is and what we can know, between the invisible and the understood. And in doing so, we become part of the story. Not just as observers, but as participants in a quiet exchange. Our curiosity draws something out of the silence. Our questions shape the way we see. And in return, Neptune gives us not just data, but meaning. It reminds us that the cosmos is not a dead place. It is alive with motion, with force, with subtle interactions that span unimaginable distance. Now imagine the field once more, Neptune's magnetic breath, flowing outward like a tide. It reaches beyond the planet's edge, touching its rings, its moons, the path once traveled by Voyager. That spacecraft, tiny and silent, passed through the field like a leaf in a stream. And as it did, it recorded the song, the hum of magnetism, the rise and fall of strength, the invisible tension of field lines under cosmic wind. That signal reached Earth, carried by light-speed waves across 1 billion kilometers, and when it did, we listened. We translated those signals into graphs and numbers, into knowledge and awe, the pulse of a planet felt across space. And yet, it was only the beginning. There is still so much we don't know. What lies deeper in Neptune's core? How exactly does the dynamo function within that exotic, icy shell? What interactions occur between field and moon, between field and ring, in the quiet moments when no storm erupts and no light flares? These questions remain, drifting in the same dark sea as Neptune itself. But questions are not the absence of knowledge. They are the shape of our wonder. They are how we approach the universe, not with conquest but with curiosity, not with control but with open eyes. So we leave Neptune's magnetic heart not with answers but with reverence. For in its uneven rhythm we find a mirror for ourselves, not symmetrical, not always predictable but still turning, still glowing, still held together by invisible forces we are only beginning to understand. And perhaps in the final breath of this story, the field is still humming. It does not end when we stop watching. It does not pause when our questions grow quiet. It continues, like a heartbeat in the deep, slow and steady, marking the passage of time in loops and sways. We will not see its center. We will not stand where it begins, but we will feel its edge again and again as we continue to reach for the sky. Neptune spins, its heart turns wide, and in that spinning the universe remembers something soft and electric and real, something we, too, carry in the currents of our own living minds. Far beyond the warm breath of the sun, past the golden light that paints our skies, there is a world that glows with no need for day. Neptune, blue, distant, frozen, does not shine like the inner planets. It does not sparkle with reflected brilliance like Venus, nor smolder with surface fire like Mercury. And yet, from that far reach of the solar system, Neptune gives off more light than it receives. It glows quietly, invisibly from within. This is a different kind of light, not the visible shimmer of sunrise or the sharp blaze of a star. It is deeper, softer, a gentle radiation born of warmth carried inside for billions of years. Neptune, wrapped in layers of ice and gas, still holds the heat of its own making, and this hidden fire, this internal warmth, whispers into the universe as a steady, glowing breath. Unlike the inner planets, Neptune receives only a tiny sliver of sunlight, less than 1,000th of what Earth does. It is so far that the sun appears more like a bright star than a blazing disk. Day and night blur into one endless dusk, and yet the planet emits about twice the energy it absorbs from the sun. Where does this extra glow come from? The answer lies not in the sky, but in Neptune's core. Long ago, in the early days of the solar system, Neptune formed from collisions, countless icy and rocky fragments crashing together in the cold reaches beyond Saturn. Each impact brought heat, and over time that heat built up inside the growing planet. And even now, billions of years later, some of that warmth remains, sealed beneath thick blankets of gas and cloud. The outer layers cool slowly, but the deep interior still stirs with energy. This heat does not rise as fire. There are no flames beneath Neptune's surface. Instead, it travels upward through conduction and convection, soft flows of warmer material moving through colder layers. The planet's dense core, likely composed of rock and exotic ices, radiates energy outward through a thick mantle of water, ammonia, and methane in forms no longer liquid or solid, but something in between. At the boundary where gas meets this ocean of pressure and chemical complexity, the internal heat rises, invisible, constant. And so, Neptune glows. We cannot see this glow with our eyes, but we can feel it in other ways. Infrared telescopes tuned to the long, soft wavelengths of heat reveal the difference between absorbed sunlight and emitted energy. The numbers don't lie. Neptune is warm inside, not warm like a summer breeze, but warm in the sense of persistence. It holds on to what it was. It remembers its own beginning. The warmth creates more than a quiet glow. It fuels the winds. It drives the storms. Neptune's atmosphere, though unimaginably cold to human skin, is restless and wild, filled with the fastest winds in the solar system. Some reach 2,100 kilometers per hour, faster than sound. These storms move in bands, shaped by the planet's rapid rotation and deep convection. They spiral into dark spots, temporary eyes in a sea of swirling gas. And all of it, every gust, every cloud, every twist, begins with that hidden heat. This internal energy shapes not just the atmosphere, but the very character of Neptune. Unlike Uranus, which radiates almost no extra heat, Neptune seems unable to rest. Its storms are more active, its winds more intense, its clouds more dramatic, and scientists still wonder why. The two planets are similar in size, similar in composition, yet Neptune burns brighter. Why does it retain so much heat, while Uranus remains strangely cold? Some theories suggest the answer lies in the layering of materials, that Neptune's internal convection moves more freely, allowing energy to escape. Others imagine a history of impact, where Uranus suffered a great collision that knocked it sideways and sealed its core. Still others speak of processes we don't yet understand, exotic physics at work in materials under unimaginable pressure. But whatever the reason, the glow remains. Not like the flare of a match, not like the glitter of stars, but like a breath in the cold. Soft, constant, alive. Neptune's glow is not meant to be seen, but felt, measured in waves beyond the visible, sensed in the movement of clouds, in the echoes of wind. It tells us that a planet need not be near the sun to shine. That light can come from within. That warmth can live even in darkness. And this perhaps is the most poetic truth Neptune offers us. That distance does not mean emptiness. That cold does not mean lifelessness. That in the silence beyond Saturn's rings, there is still energy, still motion, still light. We think of sunlight as the source of all brightness, but Neptune glows without it, not brightly, not boastfully, but deeply, steadily, like a memory it refuses to let go, a memory of collisions, of heat, of formation, a memory of being born. This glow does not flare, it does not flicker, it simply persists. And in that persistence, Neptune shows us something beautiful, that not all light comes from the outside, that even a world alone in the cold can still carry a fire inside. And so the planet turns, glowing gently in the dark, not to be seen but simply to be, still burning, still breathing, still blue. The glow within Neptune is not loud. It does not announce itself with flares or flashes. It moves like the tide, steady and unseen, winding upward from the hidden depths to touch the upper air. This light, born not of sunshine but of memory, shapes everything it touches. And if we follow it, gently and slowly, we begin to understand how a planet can shine with nothing but its own story. Inside Neptune, heat rises like a long breath. It travels through dense layers of gas and icy fluid, through regions where water, ammonia, and methane shift from one state to another, no longer behaving like familiar substances. Pressures here are so immense that hydrogen, the simplest atom, begins to change, becoming metallic, flowing, charged. The materials do not just sit, they move, they churn. They twist in great loops of slow current, carrying energy outward in ways that still surprise scientists. This deep movement drives everything above. Neptune's clouds, faint blue and high like whispers, are stirred by forces they cannot see. Bands of wind race around the planet, pulled by convection beneath. Storms spiral into existence from the gentle rising of warm gas, the quiet sinking of cold air. And all of it is fed by the internal glow, the warmth that never quite faded. In the northern hemisphere there are bright spots, high clouds made of methane ice that drift and vanish, carried by winds that never sleep. Sometimes they gather into vast systems, storms larger than Earth that spin for days or weeks before dissolving back into the blue. These storms are not born of solar energy. The sun's light is too weak here. Instead, they come from within, fueled by the leftover warmth of formation and the strange dance of deep, pressurized chemistry. What is perhaps most beautiful is how this heat becomes rhythm. Neptune's fast rotation, a full spin every 16 hours, stretches and shapes the flow of air. It forms zones, bands of motion where winds move in opposite directions, layering the atmosphere into ribbons of dynamic silence. The heat from below adds buoyancy. It drives motion upward. It creates systems of balance, swirling, rising, falling, all invisible to the naked eye, but measurable in color and temperature. The glow also influences the planet's magnetic field, in ways still being studied. As heat rises, it may stir the conductive layers inside, the slushy ocean of water and ammonia that lies above the core. This stirring creates electric currents. Those currents generate magnetism, and so the glow, thou. Quiet becomes the pulse of something larger, a breath that becomes a field that becomes protection, a shield that guides particles, sparks auroras, connects moons. Even Triton, Neptune's largest moon, may be touched by this glow. Though Triton is cold, locked in an orbit that moves opposite the planet's spin, it shows signs of activity. Geysers burst from its surface, thin plumes of nitrogen and dust rising into the sky. Some scientists believe these eruptions may be linked indirectly to Neptune's internal heat, to the way the planet's warmth shapes its magnetosphere, which in turn touches the moon, subtly stirring it. And beyond Triton lie the rings, faint, dusty arcs that circle Neptune like the memory of formation. These rings are shaped by the gravity of inner moons and the flow of charged particles. The internal glow may influence their structure too, driving changes in the field that push and pull on the dust. It is a quiet process, but over time the glow becomes a sculptor, shaping not only clouds and winds but rings and rhythms. It's easy to overlook this kind of energy. We're used to thinking of light as what we can see, but Neptune reminds us that glow can exist beyond our senses, in wavelengths too long, too soft, too deep. The infrared warmth it emits is not for the eye, but for instruments that feel with precision, that sense the subtle warmth of a planet breathing in the dark. And still, the question remains, why does Neptune glow more than Uranus? They are nearly twins in size, mass, and composition, yet Uranus radiates little to no extra heat. It is cold, slow, oddly still. Neptune, by contrast, pulses with wind and cloud and storm. Scientists wonder if Uranus suffered a great impact long ago, one that tilted its axis and locked its interior. If true, it might have sealed its heat, creating a layered boundary that resists convection. Neptune, untouched, might have remained free to move, to churn, to glow. There are other theories too, about composition, about chemical pathways, about deep oceans under unimaginable pressure. But the truth is, we don't fully know. And in that unknowing, Neptune becomes not just a planet, but a question, one that invites us to wonder, not with urgency, but with quiet curiosity. Because some mysteries do not ask to be solved, they ask only to be seen, to be honored, to be explored slowly like a soft light in the night. So what does it mean that Neptune glows? It means that a planet so far, so cold, so wrapped in storms, still carries its beginnings. That time has not drained it. That motion continues. That something deep inside still wants to rise, to move, to speak. It means that energy does not vanish. It changes, it travels, it becomes weather and wind and field. It becomes structure, it becomes balance. And perhaps it means this, most of all, that the universe remembers. That planets do not forget their birth. That glow, though faint, endures. That within each world there is a kind of fire that does not fade but flows. That Neptune, far from being a frozen silence, is in fact a place where warmth still dreams, where blue still burns, not for the eye, but for the soul. Let us sit now in the soft glow of Neptune's memory, not to measure it, not to explain it away, but simply to be near it. To imagine what it feels like for a planet to carry its own light, to shine not for attention, but because something inside never went dark. In the cold and distance where Neptune orbits, 4.5 billion kilometers from the Sun, the world is still warm. Not warm to the touch, not warm in the way we know, but warm in a deeper, older way, a kind of patience. A kind of memory. This glow is not a flare, it is not fire, it does not leap or rage, it whispers. It pulses through layers of hydrogen, helium, and methane, pressing outward from the core in slow, invisible waves. The planet does not blaze, it breathes. And each breath becomes part of the sky, part of the clouds that swirl with impossible speed, the storms that rise without sun, the rings that shimmer faintly in dust. What Neptune teaches us is this: that light is not always loud. Sometimes it is the echo of time. Sometimes it is the quiet of something that refuses to fade. The energy we see in Neptune, in its winds, its color, its magnetic soul, is not borrowed from stars. It is its own. It was made long ago and it remains, not perfectly, not unchanged, but persistently. There is beauty in this persistence, not the kind that dazzles or demands, but the kind that hums gently at the edge of awareness. When scientists first observed Neptune's infrared signature, the heat it emits, they were puzzled. It seemed impossible. How could something so far, so cold, still be warm? But that warmth was real, and it pointed toward something deeper, a planet that has kept hold of itself. In a solar system full of violent change, impacts, migrations, collapses, Neptune stands as a quiet survivor. It has no solid surface, no volcanic eruptions, no tectonic shifts. Yet it remains dynamic. Its weather moves, its fields shift, its heat escapes in subtle, elegant flows. It does not rage, it endures. And maybe that is what glow truly is, endurance made visible. Not just heat, but the will to continue, to rise through layers, to stir clouds, to be something more than cold. Even its color, that deep, luminous blue, feels like part of this quiet fire. The methane in Neptune's atmosphere absorbs red light and reflects blue, creating the shade we know. But the blue of Neptune is richer, deeper than that of Uranus. Some scientists suspect that other elements or aerosols are involved, but maybe it is something else too, the way heat and chemistry, pressure and time combine into something singular, a color that isn't just seen but felt. Imagine floating above Neptune's upper atmosphere. There is no ground, no place to stand, only wind and sky. Beneath you, the clouds stretch into long bands, whipped by winds faster than anything on Earth. Here and there, bright spots drift, methane ice catching the faint sunlight, turning it into momentary brilliance. And underneath all of this, warmth, a deep, invisible ocean of motion, churning endlessly in the dark. If you could place your hand into Neptune's depths, through the clouds, through the gas, you would find not emptiness but pressure, heat, movement. The glow is there waiting. It does not flash, it does not boast, but it never stops. And neither does the planet. It turns, it breathes, it remembers. Neptune glows not because it wants to be seen, but because it simply is. Because glow is not a performance. It is presence. It is proof that something once happened, that energy was created, stored, and shared. And in this way, Neptune becomes more than a planet. It becomes a mirror for what lies within all things that survive. There is a quiet strength in holding warmth when everything around you is cold. There is grace in moving without needing to be watched. And there is wisdom in knowing that light does not always need to come from above. As Neptune continues its slow, wide orbit, taking 165 years to circle the Sun once, it carries its glow with it like a secret. The other planets come and go in the sky, but Neptune moves in a long arc, unseen by most, untouched. And yet it shines. Even as it drifts farther, even as it enters deeper night, the glow remains. We may never land there, we may never send a human hand to touch its clouds, but we have seen its warmth, we have listened to its weather. We have read the signature of its heat in the soft curves of data, in the colored maps of infrared light, and in doing so we have come closer not just to Neptune, but to the idea that light can live anywhere. It is easy to think that only the sun gives life, that only stars hold fire, but Neptune says otherwise. It says that energy can sleep in the deep, that even when the sun grows faint, a world can still burn softly, that inside the coldest, farthest blue, there is still something bright. And perhaps this is what we are meant to carry, that even in the most distant corners of space, glow is possible. That being far away does not mean being forgotten. That stillness does not mean silence. That a planet, alone in the dark, can still hold something precious, a gentle, glowing reminder of where it began. So let us remember Neptune not just as a name or a dot or a number in a chart. Let us remember it as a presence, blue, breathing, luminous, a place where heat becomes memory, a place where glow becomes story, a place that shines not with the sun but with itself. At the edge of the solar system, where sunlight arrives as little more than a whisper, Neptune turns beneath a sky the color of deep ocean. It is a place where silence rules, where the cold stretches out like a frozen breath, and yet in this distant quiet there is something wild, something unseen but constant. The fastest winds in the solar system race through Neptune's upper atmosphere, not in howls or roars, but in invisible streams, faster than sound, faster than storms, faster than anything else the sky has ever held. These winds are not born of sunshine. The light is too faint here, too thin. At Neptune's distance, the sun offers only the dimmest warmth, barely enough to paint a shadow. Yet still the winds rise. They stretch around the planet in long, spiraling bands, moving east and west at different speeds. Some reach over 2,000 kilometers per hour. And in this contrast, between silence and speed, Neptune becomes a kind of instrument. A slow-spinning world with a breathless, invisible song. But where do these winds come from? How do they form, and how do they persist in a place so far from the heat that fuels weather on Earth? To understand Neptune's winds, we must begin deep beneath its clouds. The energy that drives this motion does not come from above, but from within. As we saw before, Neptune glows, gently, quietly, with internal warmth left over from its birth. That heat rises slowly through layers of gas, creating movement in the deep. Convection currents stir the fluid atmosphere, pushing warmer material upward, cooler material downward. This movement begins the great machine of weather. Then comes the spin. Neptune rotates quickly, once every 16 hours. This rapid spin stretches the rising currents into long ribbons that wrap around the planet's circumference. The result is a series of alternating wind bands, each flowing in its own direction. Some move with the rotation, others against it. Together, they create a layered, living atmosphere, spinning with silent momentum. At Neptune's equator, winds blow westward, opposite to the planet's rotation at record speeds. Closer to the poles, they turn eastward again, forming loops of moving air that stretch across thousands of kilometers. These opposing flows create powerful shear zones where winds meet and twist and rise. It is in these places that clouds gather, storms form, and Neptune's song begins to take shape. There are no thunderclaps here, no rain as we know it, but high in the atmosphere where pressure is low and temperatures are icy cold, methane condenses into crystals, forming thin clouds that drift like frozen smoke. These clouds trace the motion of the winds. When a bright spot appears in Neptune's upper layers, a methane storm or a swirling vortex, it is often the sign of wind beneath, moving with tremendous force. The most famous of these systems was the Great Dark Spot, discovered by Voyager 2 in 1989. It was a vast storm, larger than Earth, with winds circling its eye at nearly 2,400 kilometers per hour. Unlike Jupiter's Great Red Spot, Neptune's storms do not last centuries. The dark spot vanished within a few years, replaced by new features, new tempests rising from below. And each one is born not from sunlight, but from the quiet rising of warmth. This makes Neptune's winds unique. On Earth, wind is driven by differences in solar heating. The sun warms the equator more than the poles, and the planets spin shapes that uneven heat into trade winds, jet streams, cyclones. But on Neptune, where the sun's warmth barely reaches, the winds come from deeper forces, the leftover heat from formation, the churning of fluid layers under crushing pressure, the turning of the planet itself. And yet these winds do not tear the planet apart. They do not break the sky. They move in balance, violent in speed, but graceful in pattern. They sing not in screams, but in motion, in the way clouds stretch and curve, in the way storms spiral and fade. Some scientists believe that the wind patterns are also shaped by waves, atmospheric waves that ripple through Neptune's gases like vibrations on a drum. These waves may form from interactions between wind bands or from deeper motions within. They can rise to great heights, creating standing wave patterns that shape the distribution of clouds. In this way, the atmosphere becomes not just a system of motion, but a resonant space, a place where the forces of spin, heat, and chemistry create rhythm. And though we cannot hear these rhythms, we can see them. Telescopes tuned to different wavelengths capture the shifting clouds, the repeating structures, the rise and fall of brightness. Over time, these patterns reveal the flow of wind beneath. They allow us to track storms, to watch features appear and disappear, to measure the pulse of a planet wrapped in blue. Even Neptune's shape tells the story of its winds. Because it spins so quickly, the planet is not a perfect sphere. It bulges slightly at the equator, a response to centrifugal force, to the way the mass of the planet is flung outward by its own motion. This flattening adds to the complexity of the winds, creating additional forces that must be balanced. And somehow Neptune does. It keeps its winds moving. It sustains the pattern. The winds sing at the edge of space, not in sound but in speed, not in thunder but in the swirling of unseen currents. And what they sing is not chaos. It is not storm for storm's sake. It is a message that energy does not need warmth to move, that motion does not need light to begin. And so in the deep cold Neptune spins, the winds rise, the clouds curve, the storms bloom and vanish, and the planet continues, carrying its silent song across a sky no eye has seen. A song written in speed, in patience, in the shape of invisible air. To follow Neptune's winds is to follow a mystery. They move with such force, such speed, that even the most powerful storms on Earth seem still in comparison. And yet they are invisible to the naked eye, hidden in layers of atmosphere more than 4 billion kilometers away. It is only through careful observation, through patient listening across wavelengths of light, that we begin to see the shapes they carve, the stories they tell. Winds on Neptune do not move randomly. They form structures elegant and vast, zonal jets, storm bands, great spirals. In the southern hemisphere, bright features have been seen migrating across the planet, not drifting passively but carried by precise currents, shaped by underlying flows. These patterns show us that the winds are stable in their instability. They move, but in ways that repeat, in cycles and paths that return again and again like a song's refrain. And the origin of these winds, their true beginning, lies in the dance between pressure and heat, spin and depth. Deep within Neptune, far below the visible clouds, the planet's interior is warm. This heat, slowly moving upward through layers of gas and fluid, encounters cooler regions above. The contrast creates buoyancy, warm gas rises, cool gas sinks. The motion becomes circular. These currents stretch out as the planet spins, forming long belts of wind that wrap around its girth. The rapid rotation of Neptune bends these belts into jets. At the equator, a powerful westward jet dominates, the fastest of any planet in the solar system. Further from the equator, the winds reverse direction, flowing eastward near the poles. This alternating pattern creates sharp wind shears, regions of atmospheric tension where storms can form and grow. And these storms are no less mysterious. Some, like the Great Dark Spot, appear suddenly vast swirling systems of unknown depth. They resemble hurricanes with central eyes and spiral arms, but unlike Earth's hurricanes, they are not formed over warm oceans. There is no water vapor here to condense, no latent heat of condensation to drive them. Instead, they are powered by dynamics we are only beginning to understand, the balance of internal heat, planetary spin, and fluid motion on a scale beyond our everyday experience. These storms can span thousands of kilometers, moving slowly relative to the winds around them. They seem anchored, resisting the pull of the jet streams, possibly held in place by deeper atmospheric structures. Over time, they may shrink, fade, or be torn apart by the shifting flows. Yet while they last, they offer windows into the deeper layers of places where the usual order of Neptune's winds is disrupted, where the atmosphere rises and falls in new ways. Some storms ride the boundaries between jet streams, surfing the transition zones like waves. Others twist vertically, drawing materials from below and pushing them upward. In some cases, high clouds form above the storm, like bright white caps on a deep blue sea. These high clouds, made of methane ice, scatter sunlight and mark the locations of violent motion beneath. Even when storms are not visible, the winds continue. They form waves in the atmosphere, Rossby waves, Kelvin waves, gravity waves, rippling through the gas like tremors through a liquid skin. These waves may carry energy across hemispheres or remain trapped in belts, shaping the way clouds form, the way temperatures change. Through them, the winds become more than motion. They become communication, a means by which the planet distributes heat, maintains balance. And it is balance that defines Neptune's wind system. Despite the chaos, the great speeds, the unpredictable storms, the atmosphere remains remarkably structured. The jets hold, the bands return, the rotation continues. There is no runaway motion, no permanent disruption. Instead, Neptune shows us a form of harmony born from contrast, fast winds, slow change, violent storms, soft rhythm. This kind of harmony is not easy to grasp. It does not fit into simple equations. It must be felt, sensed through long watching and deep modeling. Scientists use simulations to recreate Neptune's winds, adjusting variables to match what is observed. These models suggest that the planet's heat and spin are enough to drive the winds, that the absence of surface friction allows the flow to persist, unhindered, across vast distances. On Earth, mountains and oceans break the wind. On Neptune, there are no such obstacles. The atmosphere moves freely, constrained only by the forces that birthed it. And so, the winds can reach their full potential, not because the planet is wild, but because it is smooth, continuous, uninterrupted. Even so, there are mysteries. Why, for instance, are Neptune's winds so much faster than those on Uranus, a planet of similar size and composition? Both receive little sunlight, both rotate quickly, and yet Neptune's winds are nearly twice as fast. Some believe it is a matter of internal structure, that Neptune's heat is more efficiently transferred, or that its internal convection reaches higher into the atmosphere. Others suggest subtle differences in chemical makeup or in the layering of gases. Whatever the cause, the result is undeniable. Neptune's winds are the swiftest in the solar system. They move like rivers of air, unbroken by land, unbothered by season. Hey, remind us that atmosphere is not passive. It is alive with force, with memory, with dance. And as we observe these winds from telescopes far above Earth, we do more than collect data. We listen. We watch the sky move. We measure the patterns of light and motion, and from them we extract something more than numbers. We extract wonder. Because in a world where the sun barely shines, where the cold is nearly absolute, a planet sings. Not in music, not in language, but in motion, pure, continuous, graceful. The winds are its voice, the clouds are its words, the storms are its stories, and all of them drift endlessly across a sky we may never stand beneath but can still understand. We may not hear Neptune's winds with our ears, but we can feel them with our minds, the rush, the sweep, the slow pulse of power. And in feeling them, we are reminded that distance does not silence. That space, though vast, still carries song. Now let us return one last time to the edge of Neptune's sky, where the winds still move in great silent spirals. We've watched them sweep across the planet with impossible speed. We've seen them sculpt storms, shape clouds, draw lines in the blue. And as we linger here at the outermost rim of our solar system, we begin to understand that these winds are not just movements of air. They are the breath of a planet, the memory of warmth, the echo of creation in motion. The story of Neptune's winds is not just about speed, it is about resilience, about the persistence of energy in a place where energy should not remain. In a world so far from the sun, where light is reduced to a whisper, Neptune still holds a storm in its heart. The winds prove that motion does not need warmth to exist. It needs imbalance. It needs space to stretch, to flow, to continue without interruption. And Neptune offers all of that, a smooth, spinning sphere with just enough heat inside to keep the atmosphere alive. Even the smallest motions here mean something. Every ripple of methane gas, every flicker of a high cloud, every tiny shift in pressure, they are part of a vast, coordinated dance. A dance that has no conductor, no script. It writes itself as it moves, shaped only by physics, chemistry, and the quiet patience of time. We often think of wind as a force we can feel, rushing past our skin, bending trees, carrying sound, but Neptune's winds are different. They exist beyond touch, beyond hearing. They are too distant, too thin, too fast. They move in a silence so complete that it becomes its own kind of music, not made of notes but of rhythm, of shape, of change. And still we hear it not through ears but through observation, through careful readings of Doppler shifts, through tracking the movement of cloud tops, through the repeated patterns found in data gathered over years. From this a melody emerges, a shape, a presence. The wind becomes not just motion but meaning. This meaning reaches out beyond Neptune, into the questions we ask about all planetary atmospheres. Why do some winds die and others endure? Why do some storms fade and others grow? Neptune challenges us to look deeper, to understand that not all weather comes from above, that sometimes it rises from within, that the force which stirs the sky may begin far below, in layers too deep to see. It also invites us to consider balance, because the winds, for all their speed, do not break the planet apart. They do not grow endlessly. They obey boundaries, invisible lines drawn by gravity, by temperature, by the composition of the gases themselves. In this way, Neptune teaches us that even the wildest motion can be held within a greater stillness. That freedom does not mean disorder. That velocity can coexist with peace. And perhaps that's the real secret of these winds. They are not a storm against the void. They are the shape of Neptune's silence, a silence that moves, a silence that turns, a silence that breathes out in soft spirals one after another without end. The winds touch everything. They shape the rings, bending dust into arcs that echo the invisible flow. They touch the magnetosphere, guiding the paths of charged particles, influencing how auroras bloom. They even reach toward Neptune's moons, brushing their orbits with faint pressure, reminding them and us that everything here is connected. From the smallest crystal of methane ice to the great bands circling the equator, all is shaped by the wind. And the wind, in turn, is shaped by the planet's heart, by the heat that still rises from the deep, by the slow, strong spin that wraps the planet in motion. We may never fly through these winds, we may never feel them against our skin, but through science, through listening, through imagining, we have touched them all the same. We have followed their path across the sky. We have traced their motion in the language of data, and we have found beauty not in the violence of their speed, but in the gentleness of their persistence. Neptune spins, its clouds drift, its storms come and go, and above it all the wind continues, unseen, unbroken, unafraid. This is not a story of destruction. It is a story of movement that lasts, of force that flows, of silence that dances. So let us remember Neptune not just as a cold blue planet, but as a place where wind becomes poetry, where air becomes a song with no sound, where motion continues, even in the furthest shadows of the sun. And as we drift away from this distant world, we carry something with us, not a sample, not a stone, but a feeling, the feeling of a sky that never stops moving, the sense that even here in the quiet, something powerful is always stirring. Winds that do not rest, skies that do not still, a planet that sings with nothing but the breath of its own deep heart. In the vast quiet where light begins to fail, there is a kind of sky no one has ever stood beneath. A sky without clouds as we know them, without moonlight or city glow. A sky of ice and magnetism where colors bloom in silence. This is where the auroras of Neptune live, not in brightness, not in spectacle, but in the softest reach of charged particles meeting atmosphere, in the coldest dark where beauty still chooses to appear. On Earth, auroras shimmer green and red, twisting in luminous arcs across the polar sky. They are driven by sunlight, or more precisely, by the solar wind, that stream of charged particles flowing from the sun's corona. As these particles meet our magnetic field, they are drawn toward the poles, where they collide with atoms in the upper atmosphere and light is born. But on Neptune, where the sun is only a dim beacon, the aurora becomes something else entirely. It is not the reflection of brilliance. It is the memory of a meeting, the invisible hand of solar particles brushing against an atmosphere too cold for clouds, too distant for day. It begins with a journey. Charged particles leave the sun, streaming outward in the wind that never stops. They pass the orbits of Earth and Mars, skirt Jupiter and Saturn, until at last they reach Neptune, where their force is faint but not gone. Here they are caught by the strange geometry of the planet's magnetic field, a field tilted and twisted off-center, wrapped in a dance of its own. Neptune's magnetosphere does not form a perfect shield. It bends and flows like a curtain in cosmic wind. Some particles bounce off, others slip inside, caught in spiraling paths that lead toward the poles. When they arrive, they find the thin upper atmosphere, hydrogen and helium, mixed with traces of methane, and there they release their energy. They spark ultraviolet light, light too soft for the human eye, but light all the same. This is Neptune's Aurora. It does not dazzle, it does not wave in sheets of color across a black sky. It flickers, it breathes, it pulses in ghostly rhythms, seen only through the instruments tuned to the right kind of light. The Hubble Space Telescope, sensitive to ultraviolet, has caught brief glimpses of these moments. Faint arcs, curves of brightness traced across the terminator line where day meets night. Signs that the aurora dances, even if no one watches. And the dance is not random. It follows the lines of the magnetic field, lines that are constantly shifting, swaying as the planet spins. Neptune's magnetic poles are not near its geographic ones. They are far off and they move as the planet turns. This means the auroras do not settle in steady rings around the poles. They appear in drifting patches, moving across latitudes, changing with the wind of space. It is a strange kind of performance, one where the dancer changes costume with every turn. But why does it matter? Why care about a glow so faint, so distant, so different from the auroras we know? Because it reminds us that beauty is not limited by light. That color can exist in shadow. That even in the coldest places, where time feels slow and sound is swallowed, something luminous can still emerge. And more than that, it reveals the invisible threads that tie our solar system together. The solar wind, born in the same star that warms Earth, still touches Neptune. The same particles that stir our own skies in green fire also reach across space to brush against the edges of a frozen world. And in that touch, brief, quiet, delayed by distance, something new is born, a light that does not need to be bright to be real. Neptune's auroras may also carry messages, not in language but in patterns. Variations in brightness, in location, in timing. These variations tell us how the magnetic field moves, how the solar wind shifts, how the space around the planet responds. By watching these changes, scientists can learn about processes far below the surface, about how energy flows through the planet's core and out into space. It is a kind of listening, a kind of reading. The aurora becomes a journal written in ultraviolet, read by eyes that see without seeing. And within that journal we find rhythm, a heartbeat, a presence. It reminds us that Neptune, far though it is not silent. It speaks. Not in sound, not in movement we can touch, but in light, faint, distant, persistent, the kind of light that lingers in memory more than sight, the kind that means something because it exists at all. There is a quiet dignity in this. Neptune does not shine like the sun. It does not glow with fire or glitter with rings of ice like Saturn, but it offers a subtler kind of light, one born of connection, one that comes from being part of a larger system, from being touched by wind that crosses billions of kilometers. The aurora is not just a visual event, it is a story of interaction, of field and flow, of motion and matter. It is a dialogue between sun and planet, star and atmosphere, across the cold, across the dark. And so we watch, we listen, we trace the patterns of ultraviolet arcs and learn to hear the music of particles in flight. Because when Neptune glows, it tells us that nothing is ever truly alone, that even in the furthest orbit, even in the frozen dark, there is still the memory of warmth, the movement of wind, the brush of a star. And that sometimes is all it takes for light to begin. To understand how aurora dances in the darkest cold, we must linger in the space where light becomes breath, where charged particles drift like whispers along invisible lines. Neptune's auroras are not simply flashes of brilliance, they are patterns, shaped by the planet's magnetism and the solar wind's delicate touch. Each flicker is a sign, a meeting between energy and matter, between force and field. The planet's magnetic field is not anchored like Earth's. It is tilted, shifted, and curved, offset from the center and tangled in its flow. As Neptune spins, this lopsided field sways and turns through space, shaping its magnetosphere like a ribbon twisting underwater. The field does not stay still. It pulses, it warps, and in doing so it draws particles from the solar wind into a slow spiral, guiding them inward to where they can bloom as light. These particles do not crash all at once. They drift, they circle, caught in long arcs that follow the curves of Neptune's magnetic field. It is a slow dance, not a collision. The particles gain speed, spiraling along field lines until they finally strike the thin atmosphere, mostly hydrogen, laced with traces of methane and helium. When they arrive, they excite the atoms and molecules, causing them to release energy in the form of photons. But these photons lie mostly in the ultraviolet range, a spectrum beyond what human eyes can see. What we would witness if we could is not a glowing green curtain, but a faint, ethereal shimmer, a brief arc of pale violet curling near the edge of the planet's shadow, an aurora that flickers once, then fades into the cold. Its beauty lies in its elusiveness, always moving, always changing, never quite the same. Yet for all their gentleness, Neptune's auroras hold great meaning. They are keys to understanding how the planet interacts with its space environment. They show us how the magnetosphere responds to solar pressure, how particles are trapped or deflected, how the field lines bend and flex in the deep dark. Each aurora is a kind of map, a moment where the invisible becomes visible. Scientists track these moments through ultraviolet telescopes, watching the pulses, tracing the arcs. In doing so, they uncover patterns, bursts of auroral light that match the planet's rotation, that vary with solar activity, that mirror changes in the solar wind's density and speed. In this way, the aurora becomes a diagnostic tool, a way to see the unseen, to feel the planet's pulse without touching it. And this pulse is irregular. Neptune's auroras do not form stable ovals like those on Earth or Jupiter. They wander. They appear in unexpected places, shaped by the planet's chaotic magnetic structure. Some may form far from the magnetic poles. Others might circle and fade before completing a ring. This behavior is not an error, it is an expression of Neptune's nature. The field is offset, generated in layers of conductive ice and fluid far above the core, and this displacement creates complexity. As a result, the auroras reveal a magnetic world in motion. But the dance of aurora is not only shaped by magnetism. It is also touched by rotation, by moons, by time. Neptune's rapid spin causes the field to sweep through the solar wind like a great arm, gathering and compressing particles in the planet's wake. As this tail stretches, it may snap and reconnect, flinging particles back toward the atmosphere in bursts that light up the poles. These reconnection events could cause brief, bright auroras, sudden flashes in a sea of darkness. Triton, Neptune's largest moon, may also play a part. Though its orbit is distant, it moves against Neptune's rotation, a retrograde path that stirs the magnetosphere. Its presence may twist the field, creating subtle currents and disturbances that shape the auroral glow. In this way, aurora becomes not just a meeting of sun and planet, but of moon and magnetism as well. And perhaps that is the most poetic truth, that aurora is not the work of a single hand. It is collaboration, the product of fields and particles, of motion and matter, of rotation and rhythm. It is a painting drawn not with brushes but with ions, a dance choreographed by forces that do not see but still respond. Each aurora, even the faintest one, carries echoes of distant fire, of solar eruptions that left the sun days or weeks before, that traveled billions of kilometers to arrive in silence. That journey alone makes each flicker sacred. The light we see on Neptune is not its own, but borrowed, transformed, released. A final exhale of a long cosmic breath. And yet there is something undeniably Neptunian about this light, the way it appears briefly, unpredictably, the way it never quite fits the pattern, the way it refuses to be pinned down. It mirrors the planet's winds, its storms, its field, beautiful, wild, and forever turning. In this turning, the aurora becomes a clock, a pulse we can follow. As Neptune spins, we watch the aurora shift and fade. From this, we measure time on a planet no human has visited. We sense rhythm in the movement of its sky. We learn how solar cycles influence even the farthest worlds. The aurora is Neptune's way of telling us where it is, how it moves, how it lives. And in the end, it tells us something else too, that even in the darkest cold, motion continues, that particles still dance, that fields still flow, that light still finds its way. We cannot see Neptune's aurora with our own eyes, but we can feel it in the data, in the patterns, in the deep truth that something distant is still glowing. And in that glow, we see more than just science. We see connection, between worlds, between forces, between time and space. Aurora is not just a phenomenon. It is a reminder that the universe is alive with meeting points, that every field waits to be touched, that every darkness still holds the possibility of light. Now let us linger in the quiet afterglow of Neptune's aurora, not to study it more, but to sit gently in its meaning. We have followed the path of particles, seen how they move through the magnetosphere, how they brush the high air and spark light. We have traced their journey across space and time. And now, in this stillness, we let the story settle like light settling softly onto a planet wrapped in blue silence. Because the aurora is not only about light, it is about response. It is about the way a planet receives what the universe offers, even at the edges, even in the cold. Neptune does not seek the aurora. It does not call the solar wind to itself. And yet, when that wind comes, the planet answers. Not loudly, not in spectacle, but in a flicker, in a moment of violet, in a curve of brightness that appears and fades without a sound. That is the essence of Neptune's sky, not to shine, but to remember, to hold quietly the energy it has gathered, to release it slowly in light that cannot be seen, but that still reaches us in its own way, through data, through rhythm, through the way it moves us when we begin to understand what it means to glow in darkness. Because Neptune's aurora is not made for eyes, it is made for time, it is made for patience. It is a story told so slowly that only the careful can hear it and only the quiet can truly listen. When the light appears, it does not rush. It curls along magnetic paths, slips across the atmosphere, pulses once and fades. And in that fading it leaves a trace, a memory of meeting, a soft reminder that motion still matters. And perhaps that is what makes it beautiful. Because it is not necessary, it is not required for Neptune to glow. The planet would still spin, the winds would still rush, the storms would still rise. And yet the aurora comes, it visits, it writes itself across the sky like a poem written only for the wind. That it happens at all is a quiet miracle, a product of forces invisible, intangible, but deeply real. It reminds us that beauty does not always demand to be seen, that some of the most profound moments unfold without witness, that a flicker of light, drifting across the top of an alien atmosphere, can carry meaning even when no one is there to name it. And as we reflect, the aurora becomes more than an event, it becomes a lesson. It teaches us about resilience, how energy endures across space, how motion can bloom in even the farthest cold. It teaches us about connection, how one breath of solar wind can travel 1 billion kilometers and still leave a mark. And it teaches us about humility, how the universe moves whether we are watching or not, how it continues in patterns too vast and subtle to ever fully grasp. There is peace in this. The aurora does not ask for attention, it does not perform, it simply is. Like a sigh from the cosmos, it comes and goes without demand. And in that gentle rhythm, we find a kind of truth that goes deeper than knowledge, the truth of existence, of presence, of being touched by light and letting it pass through us, transformed. And so Neptune spins, the particles fall, the atmosphere receives, the light flickers once, maybe twice. It may not come again for days or weeks or years, but when it does, it will do what it always does. It will rise from the meeting of energy and matter. It will curl in a soft arc. It will say, without sound, that motion still lives here. Even now, scientists watch from far away. They peer through telescopes, they filter wavelengths, they build models to predict when the next aurora might appear. But even as they calculate and measure, something more happens. They wonder, they marvel. They feel what it means to witness light born not of fire, but of encounter. And in that feeling, science becomes poetry. Because this is the gift Neptune offers, a chance to understand that not all light is bright, and not all motion is loud, that the deepest beauty may lie in the quietest flicker, the softest transformation, the slowest glow. And when we leave Neptune's sky, when we turn our instruments away or turn our thoughts back to Earth, we carry something with us. A sense that even the most distant worlds are not empty, that they are full of moments of dances, of quiet truths unfolding in the dark. The aurora, in the end, is not just a flash of light. It is a meeting place. It is where forces become form. It is where time becomes rhythm. It is where darkness is interrupted, not broken, but touched, gently, reverently, by something that reminds us we are part of a universe that breathes and burns and glows in every corner. Even here, even now, even on Neptune, where cold rules and silence reigns, the sky still finds a way to shine. And that perhaps is all we need to know, that in the deepest cold, in the farthest dark, there is still a light that dances. Far beyond the warmth of memory, past the planets we know and the sunlight we feel, there is a place where light travels differently. A place where it stretches longer, grows thinner, and becomes something almost ancient, not in age, but in the way it fades without vanishing. Neptune moves through this space, carving a path that takes 165 Earth years to complete. Its orbit is slow, silent, and so distant that the light it receives from the sun arrives like a fading whisper, not gone, but almost forgotten. This is the orbit of forgotten light. Neptune's journey around the sun is not hurried. It moves with patience, tracing a wide ellipse so vast that entire human lifetimes pass without the planet completing a single loop. Since its discovery in 1846, Neptune has traveled only once around the sun, just one circle, one arc through the dark, and still it moves steady, unseen by the naked eye, untouched by our seasons, unhurried by our clocks. Its place in the solar system marks the outermost edge of what we once called the known planets. Beyond it lie smaller bodies, Pluto, Eris, Makemake, but Neptune remains the last of the giants. The final guardian before the sun's presence begins to dim into the interstellar beyond. Its orbit defines a kind of threshold, the place where the sun's light stops being strong and starts being remembered. The sunlight that reaches Neptune is 90 times weaker than what touches Earth. It arrives with softness, barely enough to scatter in the methane haze that colors the sky a deep and glowing blue. It casts no sharp shadows, it warms no soil. Instead, it lingers like a trace, a memory of fire across billions of kilometers, and still the planet turns. Still, it reflects what little light it receives, returning it outward to those who seek it from afar. Neptune's orbit is not just long, it is lonely. At its average distance of about 4.5 billion kilometers from the Sun, it takes more than 4 hours for sunlight to reach it, a delay that turns each day into a long conversation with the past. When light touches Neptune, it is not the light of now, it is the light of then, and in that delay we begin to see time differently, not as a line but as a drift, not as a rhythm but as a breath held and released over centuries. This distance shapes more than just illumination. It defines how the planet sees its neighbors. From Neptune, the inner planets are mere points. Earth becomes a speck, Mars a shimmer, Venus a bright dot. Even the mighty Jupiter lies far behind. The Sun itself appears no larger than a brilliant star, not the disk we know, not the flame we feel, but a source of guidance more than heat. And yet Neptune remains tethered to it, pulled gently by gravity through its endless arc. This pull is not a leash, it is a link. Gravity connects Neptune to the Sun in the same way it connects all things in orbit, with silence, with certainty. There is no rope, no beam, only the constant, invisible curve that holds planet to star, moon to planet, particle to force. And in this curved motion, Neptune continues, not as a rebel, but as a part of a system still unfolding. Its slow orbit also shapes its seasons. A year on Neptune is a lifetime to us, and so each season spans more than 40 Earth years. Summer and winter last not months, but generations. Autumn and spring are measured not in days, but in decades. And though the Sun's light changes little in intensity from one side of Neptune's orbit to the other, the planet tilts, just like Earth, giving rise to long, slow changes in its atmosphere. During southern summer, parts of the planet receive slightly more light. Subtle shifts in brightness and temperature ripple through the clouds. Storms grow more visible. Methane clouds gather in spirals, but it is never warm. The temperature remains close to -220 degrees Celsius. Still, Neptune breathes in its own way, not with warmth, but with motion. The orbit may be cold, but it is not still. And in that motion, Neptune's moons follow, especially Triton, the largest, locked in a dance of its own. Triton orbits Neptune in the opposite direction of the planet's spin, a strange and rare arrangement that suggests it was once a wanderer, captured long ago. As Neptune moves around the Sun, Triton circles it again and again, tracing tight loops within wider ones, riding arcs inside arcs in a ballet of gravitational grace. All of it, the orbit, the moons, the tilt, the timing, is shaped by distance, by slowness, by the kind of space that stretches light thin and makes each movement matter. And in that space, Neptune shines in its own way. Not brightly, not quickly, but persistently. The light it reflects is dim but steady. It is not forgotten light because it is lost. It is forgotten because we from Earth so rarely see it. It does not claim attention. It does not demand wonder, but it offers both if we are willing to look long enough. Astronomers peering through telescopes have watched Neptune's orbit carefully. They have measured its motion, traced its path, even found new planets beyond by the way it moved. Neptune's orbit once told us where to look for Pluto. Its small deviations, tiny shifts in position, hinted at forces unseen. And though those deviations were later understood differently, they remind us how one orbit can shape another, how gravity is a conversation whispered across the dark. So now, as Neptune continues its slow procession, we pause and listen, not for words, not for brightness, but for presence, for the way the planet returns again and again to the same path, the same long ellipse carved through space and time. It is not lost, it is not wandering, it is simply moving at a rhythm larger than ours, a rhythm of light stretched thin, of seasons measured in lifetimes, of years that become history before they become complete. This is the orbit of forgotten light. Not light that has vanished, but light that waits, that takes its time, that knows how to move even when no one is watching. And in watching it now, we begin to remember. To follow Neptune through its long, cold orbit is to enter a rhythm that does not match our own. It is to watch a planet drift through a darkness we can barely imagine, guided not by light, but by gravity's quiet hand. In the deep space it moves through, where the sun's warmth grows thin and starlight sharpens into clarity, Neptune carries on, not slowly by its own measure, but slowly by ours. What seems distant, nearly frozen in time, is in fact part of a celestial tempo too large for a single lifetime to grasp. As Neptune circles the Sun, its position shifts so gradually across our sky that change feels almost still. For decades, it seems to hang in the same constellation, like a blue dot pinned among the stars. But it moves, always, and in that movement it reshapes the subtle balance of the outer solar system. Its gravitational influence reaches beyond what we can easily see. It tugs on small icy bodies in the Kuiper belt. It shapes the orbits of minor planets and comets. It keeps harmony with its fellow giants through orbital resonances too slow for eyes, too perfect for accident. Long ago, Neptune's migration may have rearranged the outer planets themselves. Scientists believe that after its formation, Neptune drifted outward from the Sun, carving through the disk of icy debris, scattering small worlds, capturing some as moons and disturbing others into tilted orbits that still carry their signature. Triton, with its retrograde motion, may be one such captured world, a reminder that Neptune's orbit is not only a path, but a history. The slow curve it traces is shaped by time not as we know it, but as the solar system knows it, in epochs, in millions of years. Each revolution is a sweep of S. Chi, an engraving of gravity, a circuit through the vastness. And with each orbit, the planet turns not only in space, but in relation to everything else. As Neptune completes its circle, the Sun moves, the stars shift, and the galaxy itself twists on a deeper axis. It is strange to think of light as forgettable. We are used to light as immediacy, the present moment, the sunbeam on skin, the flash of lightning. But the light Neptune receives is not immediate. It is aged, delayed, softened by distance. It carries the memory of its departure. It left the Sun 4 hours ago, and in that time everything has moved: the Earth, the Moon, the clouds, even thought. And yet the light arrives. It touches Neptune's clouds. It reflects. It moves on. And that reflection, though dim, is not lost. It travels back into space, spreading outward. Some of it reaches us. Telescopes on Earth and in orbit catch glimmers of Neptune's shine, not sunlight exactly, but sunlight returned. A signal that the planet is there, that it lives, that it still dances in the slow orbit of forgotten light. Even its color, that rich, brilliant blue, speaks of light transformed. Methane in the upper atmosphere absorbs red light and reflects blue, giving the planet its sapphire hue. But the exact shade is more vivid than expected. It's deeper than Uranus, more luminous, more alive. Scientists suspect there is more at work: aerosols, unknown particles, delicate hazes stirred by internal heat or chemical reaction. But whatever the cause, Neptune's color is part of its identity. It is not just a planet in orbit. It is a presence, a light catcher, a distant ember glowing with grace. And the way it moves, tilted but consistent, adds yet another layer to this story. Neptune's axial tilt of 28.3 degrees gives it seasons, just as Earth's tilt gives us hours. But its seasons are drawn out like ancient songs. Each one lasts over 40 years. Winter and summer do not alternate quickly here. They unfold like chapters in a very slow book. Atmospheric changes happen not in days but in decades, and yet they happen. The clouds shift, the storms form. The brightness varies. From Earth, we've begun to notice these changes, slight increases in cloud activity during certain parts of Neptune's orbit, subtle patterns that suggest a planetary response to sunlight even at this great distance. The light may be faint, but it still matters. It is still enough to stir motion, to set things turning. And in that response, we are reminded that even dim light has power, that even the weakest touch can guide, can shape, can begin a dance. Beyond Neptune, the solar system fades into a realm of shadows and drift. The Kuiper belt, the scattered disk, the Oort cloud, regions where ice and silence dominate. But Neptune is not part of that silence. It stands just before it. It is the last bright marker in a map that leads outward into mystery. Its orbit is the final circuit of a giant before the great slow sea of the outer dark. And within that orbit, time holds its breath. A single year spans generations. A single loop tells the story of change across centuries. In 2011, Neptune completed its first full orbit since its discovery. The planet returned to the same part of the sky where it had first been seen, but everything around it had changed. The Earth, the instruments, the people looking up. Neptune remained, turning, moving, remembering. Perhaps this is what the orbit of forgotten light really means, not that the light is truly forgotten, but that it waits, that it lingers, that it moves in a way that asks us to slow down, to match its pace, to watch with patient eyes and a quiet heart. It is an invitation to see beyond our scale of time, to consider rhythms that stretch further than we do. In this way, Neptune teaches not just about planets, but about perspective, about presence, about how to be a part of something vast without needing to be at its center. It moves with dignity, with grace, with a kind of soft certainty that needs no audience. And as we observe it, as we mark its path and map its light, we are reminded that our own journeys are also orbits, not always visible, not always fast, but meaningful. That we too move in long arcs shaped by gravity and memory, that we too reflect light that began somewhere else. So let us stay here just a moment longer in the space Neptune passes through. Let us watch the shadows it casts, the reflections it returns, the light it holds even as it fades. Let us learn what it means to move slowly and still be strong, to receive light that others have forgotten and turn it into something lasting. Because forgotten light is never truly lost. It waits to be seen again. Let us now walk with Neptune along the last stretch of its orbit, not as scientists, not even as storytellers, but simply as observers of time, time stretched so wide it becomes almost still. We have followed the planet through seasons that sent generations, through light that travels hours just to reach it, through a dance around the sun so slow it humbles every ticking clock on Earth. And here, at the far edge of that orbit, we begin to understand what it means to remain in motion, even when the world is quiet. There is something sacred about a path that takes 165 years to complete. It is not a sprint, not even a marathon. It is a pilgrimage carried out in silence, wrapped in cold, shaped by gravity. Neptune's orbit is not just a loop. It is a cycle of remembering, a way the universe holds onto light and releases it again, not in a flash, but in a long, soft arc across space and time. When Neptune reached the place in the sky where it was first seen, one full orbit after its discovery, no one alive at that earlier moment remained. The planet came home to a gaze that had changed. New eyes, new questions, new tools looking up. And yet the same planet, the same path, the same light, altered only by time's slow unfolding. It's easy to forget this in a world that prizes speed, but Neptune never forgets. It turns, it circles, it remembers the light. It teaches us that motion does not need to be fast to be meaningful. That distance does not erase connection, that even on the farthest path something steady still shines. We watch it now with instruments more powerful than ever, space telescopes that read in infrared, radio, ultraviolet. We track the slight wobbles in its orbit, measure the brightness of its clouds, model its interior. We are closer than we've ever been in understanding it, yet the mystery remains. Not because Neptune hides, but because it reveals itself slowly in layers like the orbit it travels. Its journey is not one of surprises, but of unfolding. We don't expect sudden turns, we look for rhythms. We study slow shifts in brightness, subtle changes in wind patterns, soft tilts in field lines. It is a science of patience. A science of returning to the same point again and again and finding something new each time, not because the planet has changed, but because we have. And in this orbit, we are reminded of the nature of light itself. What begins at the sun, a particle, a photon, races outward at 300,000 kilometers per second. It takes just over 8 minutes to reach Earth, but 4 hours to reach Neptune. By the time that light arrives, it has traveled through a region where dust hangs like forgotten snow, where comets drift in slow ellipses, where space itself begins to feel heavy with stillness. And yet the light makes it. It touches Neptune's clouds, reflects, continues. Then it begins the journey home, not home in the sense of destination, but in the sense of meaning, toward eyes that might catch it, toward detectors that might measure it, toward minds that might understand what it tells. The reflected light of Neptune carries history. It holds the echo of a star, touched and returned by a planet circling in the cold. In that journey, light to planet, planet to us, something quiet happens. A kind of connection forms, not through proximity, but through persistence. The light that left the sun now reaches us again, changed by what it passed through, shaped by what it touched. And this tells us something essential about existence itself, that everything we see is a kind of memory, that every gleam from Neptune is a message delayed, a story already in motion by the time we receive it. And what is that story? It is not a loud one. Neptune does not crash or blaze or erupt. It spins, it orbits, it holds, it reflects, it endures. Its orbit is not written in fireworks, but in fingerprints of gravity, in equations that stretch across space like songs carried by wind. It teaches us about the power of return, the strength of circling back, not because the old path is better, but because it has depth, because each return allows for another chance to see what was missed the first time. Neptune's orbit is not repetition. It is growth. It is knowing that no step is ever truly the same as the one before. And when we speak of forgotten light, we begin to see that it was never the light that was lost, it was us. We were the ones who forgot to look. We turned our eyes inward, downward, toward our own brightness. But Neptune and its orbit and the light it holds waited. And now we remember. We remember that the universe moves with or without us, that the stars shift, that the planets turn, that some lights fade only because we stop reaching for them, But the light itself, it remains, it travels, it endures. Neptune is not a dark place. It is a lantern wrapped in distance, glowing softly with reflected memory and internal breath. And so, as it continues its endless orbit, as it carves its path one more time through the vast ocean of space, we see it not just as a planet, but as a keeper of rhythm, a steward of time, a witness to the long, slow unfolding of what it means to belong to a system that spins and LDS and returns. We do not need to rush to follow it, we only need to listen, to wait, to trace its light, soft and sure, across the sky we thought we knew. Because there is light in all things, even in the most distant cold, and Neptune, moving through the orbit of forgotten light, shows us how to find it again. Not through speed, not through force, but through stillness, return, and wonder. Storms on Neptune are not like the tempests we know. There are no raindrops falling on leaves, no lightning cracks across a darkened sky. Instead, they manifest as immense, smooth-spinning vortices, great spirals of methane clouds curling in silence. They form without warning and fade without sound. The most famous of these was the Great Dark Spot, a vast storm the size of Earth, discovered by Voyager 2 in 1989. Unlike Jupiter's ancient, enduring storms, Neptune's are brief. They appear like whispers and vanish like breath. But though they are silent, they are not still. Winds in these storms can reach over 2,000 kilometers per hour, the fastest in the solar system, and they do not stay fixed. They drift, they migrate, they deepen and dissolve as though the planet itself breathes them in and out. Yet for all their strength, they make no sound we can hear. They do not break the clouds with noise. Their presence is known only by the way the light bends, by the motion of high-altitude haze, by the ghostly traces they leave behind. Each storm is a spiral of hidden energy, a dance of chemistry and pressure. Within them, methane freezes into ice crystals. Ammonia floats upward, invisible but active. The clouds rise and fall in vertical sheets, responding to temperature gradients too subtle for human senses. Sometimes bright companion clouds form above the storm, high, white, frozen, like flags marking the vortex below. These clouds are among the most visible features on Neptune, glowing in sunlight that is barely more than a trace. And still there is no thunder, no downpour, no cracking skies. Neptune's storms echo in other ways, in the distortion of the magnetic field, in the slight warming of the stratosphere, in changes that ripple through the wind belts around them. Some of these echoes are physical, some are mathematical patterns observed across time, changes in cloud brightness and motion. They are the fingerprints of storms long gone, their presence remembered not in ruins but in rhythm. Why are Neptune's storms so transient? Why do they form and fade so quickly, while storms on Jupiter last for centuries? One answer may lie in Neptune's internal structure. The planet has no solid surface to anchor these weather systems. Beneath the clouds, the pressure rises until gas becomes fluid, and deeper still, strange, supersonic oceans may churn seas of water and ammonia under extreme pressure. In such an environment, storms can drift freely. They are not pinned, they are not slowed by friction. They move with the currents beneath them, and if those currents change, the storms dissolve. Another clue lies in Neptune's heat. As we have seen, the planet emits more energy than it receives. That internal warmth drives convection, causing warm material to rise and cooler gases to sink. These slow but powerful flows can feed storm systems, but they can also destabilize them. A change in the deeper layers may break the balance, and a storm that once raged for weeks might fade in a day. There is also the question of scale. Neptune's atmosphere is vast. Its cloud tops stretch thousands of kilometers in every direction. A single storm, no matter how large, is just a feature on the edge of a great sphere of motion. And so storms may vanish not because they end, but because the planet moves on, because the winds carry them into regions where they no longer thrive. The storm doesn't die, it disperses. It becomes part of the wind again. And so what Neptune gives us is not a spectacle of destruction, but a cycle of transformation. Storms come not to end, but to change. They arrive quietly and leave gently. And in between, they shape the atmosphere in ways we are only beginning to understand. We watch them through telescopes, Hubble, Keck, the James Webb Space Telescope. We see dark spots appear near the equator, then drift slowly toward the poles. Some reverse direction, some shrink and vanish, others split in two. Each tells a story of motion beneath the visible. Each is an expression of something deeper, the churn of warm gas, the weight of ancient pressure, the breath of a planet still alive. Even in their absence, the storms remain. They linger in the patterns they left behind, in the slight bulge of a wind band, in the ghost trace of a cloud still swirling. They echo in the models we build, the simulations we run, the questions we ask. What caused this one to appear? Why did that one fade? Could it return? And always the silence answers. Not with noise but with motion, not with thunder but with pat. Neptune's storms do not shout, they whisper, and if we listen with enough patience, we begin to hear the shape of their song. It is not a song of violence but of balance, not a crash but a current, not an explosion but a slow, steady unfolding. These are the echoes of Neptune's storms, and in their quiet, they speak more clearly than sound ever could. To trace the path of a silent storm is to follow motion without noise, a pattern without a roar. On Neptune, storms are written into the atmosphere like soft spirals in frost, rising and vanishing before they can be fully understood. But though their voices are still, their effects ripple far beyond their shape. Each vortex, each shifting mass of cloud, is part of a larger conversation, one held between layers of pressure, heat, and invisible forces. The atmosphere of Neptune is not a passive place. It is alive with flow, bands of wind moving in opposite directions, temperatures layered with precision, and eddies forming where boundaries clash. It is within these boundaries that storms are born. They are spun into existence by the planet's fast rotation, by differences in heat, by gradients in composition. Unlike Earth's storms, which gather from moisture and land-sea contrast, Neptune's arise from pure dynamics, from the subtle architecture of motion in a giant fluid world. When Voyager 2 flew past Neptune in 1989, it saw a planet active and wild, with bright clouds racing through the blue and a massive dark storm near the equator. This storm, the Great Dark Spot, had the hallmarks of a vortex, winds circling around a central low-pressure region, methane clouds condensing into icy caps at high altitude, the outer edges spinning at supersonic speeds. It looked like Jupiter's Great Red Spot, but its fate was very different. Within just a few years, the Great Dark Spot had vanished. Telescopic observations later revealed more such features. Smaller dark spots appeared, then dissolved. Some drifted across the planet, others seemed to fade in place. But always the silence remained. The storms did not crash or flare. They moved, they transformed, and they left behind clues, changes in cloud bands, variations in wind speed, subtle shifts in brightness. In these clues, scientists began to hear the echoes. One echo lives in the data, the numerical footprints of change. Instruments sensitive to heat and light show how storms affect the stratosphere above them, sometimes warming the air slightly, sometimes altering its chemistry. The movement of the storm draws material upward from deeper layers, possibly even reshaping the altitude at which methane freezes. In this way, storms become more than localized events. They become engines of vertical motion, stirring the planet's atmosphere from within. Another echo lives in the wind itself. As storms form and decay, they transfer momentum to surrounding flows. They slow some winds, speed others. They leave behind traces like ripples on a pond. These ripples may interact with neighboring bands of air, setting off new waves, seeding future storms. Thus, Neptune's storms are not isolated. They are linked, each one affecting those that come next, in a cycle of influence that extends across years. Even more mysterious are the echoes in the magnetic field. Neptune's field is unusual, tilted and offset, complex in its geometry. Some scientists wonder whether storms, especially those that reach deep into the atmosphere, might influence electric currents in the conductive layers below. The motion of charged particles within storms could, in theory, generate local fluctuations, small distortions that ripple outward into the field. Though these effects are subtle and hard to measure, they offer a hint of connection between weather and magnetism, between storm and structure. And then there are the echoes in memory, not the planet's but ours. Each time we observe a storm on Neptune, we record it. We trace its curve, its drift, its brightness. We compare it to past storms. We search for recurrence. In doing so, we begin to build a kind of planetary diary, a record not only of storms but of Neptune's breath. This diary is incomplete. Most of Neptune's surface remains unobserved for long periods. The planet rotates every 16 hours, but from Earth we catch only moments. A storm may form and vanish between glimpses. Yet even those moments teach. They show us how a gas giant lives, not in fire or flare, but in motion that is patient, deliberate, soft. Neptune is not a planet of explosions. It is a world of waves, of systems that rise like thoughts and fade like sighs. And this motion reveals something unexpected, that even in chaos there is order. Neptune's storms may be fleeting, but they are not random. They form where conditions align, where temperatures shift, where flows converge. They obey rules, even if those rules are not fully understood. And those rules leave traces, echoes that whisper through the atmosphere long after the storms are gone. Perhaps the most profound echo of all is the sense of rhythm they create. The knowledge that Neptune's storms come and go not by accident, but as part of a greater cycle, one that we are only beginning to sense. There may be seasons shaped by the planet's long orbit. There may be patterns in the deep convection, rising and falling in hidden loops. And in these patterns, storms may emerge not as outbursts, but as expressions, as visible signs of a deeper, older movement. We cannot hear them, we cannot touch them, but we can see their shape, their path, their vanishing. And in that vanishing, we find meaning. Neptune's silent storms do not fade because they are weak. They fade because the planet is always moving, always changing, always balancing itself anew. Each storm is a moment, a breath held, then released, and the echo it leaves is not silence, but story. A story of motion without sound, of power without force, of storms that speak in waves, in spirals, in the slow, soft shape of change. Neptune's storms, though brief and voiceless, carry with them a final lesson, one that rises gently from their silence. They remind us that not all power announces itself, not all motion seeks attention. Some forces are quiet, slow, and deep, the kind that do not crash but turn, that do not strike but spiral. These silent storms, swirling across a world of endless blue, reflect something human too. The way we hold thoughts that never become words, the way emotions pass like clouds seen only in how they shape us. Neptune spins with these storms, not as a place of drama, but of steady transformation. Each vortex comes and goes, not to destroy, but to renew. Each one leaves an imprint in motion, a memory of balance restored. Even now, the planet turns. Somewhere in the far dark, another storm may be rising slowly, silently, becoming. It will not call out, but it will echo long after it is gone. Because silence is not absence, it is presence shaped in a different form. And on Neptune, silence storms across the sky like a thought the universe never quite finishes, but never lets go.